Hello and welcome to Unacademy, a one-stop destination for all English medium civil service aspirants. Welcome to the one-shot marathon on ISRO's roadmap for the future. In today's session, I will discuss about some future missions of ISRO. You can download the annotated PDF of the session from my Telegram channel, the link for which is provided here. Before I start the session, a very important announcement. If you are preparing for 2026 and beyond, you can get a holistic coaching with the key benefits like the complete syllabus coverage, access to all the batches and courses, including GS, CSAT, test series, and special dedicated doubt solving sessions, all at just 19,999 plus 12 months free extension. And our dedicated UPSC mains batch, Nischay 2026, provides complete UPSC mains coverage with all the 4 GS papers and the essay paper, with mock drills every week, mock tests with model answers, and dedicated mains notes with one-page summaries, all at just 9,999. The offers end tonight, so do enroll before it is late. Don't forget to use the code IAS English. Let us start the session with the first mission, that is Mars Orbiter Mission MOM-2 or the Mangalyaan 2. I hope my audio and video are completely clear for all of you. So do let me know in the messages once so that we can continue. Yes, once again, good afternoon all of you. Right, hope the audio video is clear. Okay, so as I already told you, we are going to discuss the future missions of ISRO, not the recent launches. One of the future missions is the Mars Orbiter Mission 2. You all know that the Mangalyaan 1 or the Mangalyaan or the MOM, the first mission, was a very successful one, and also we have a world record in the name of the Mars Orbiter Mission. That is, the first country, India became the first country to launch an orbiter to the Mars in its first attempt. And also it is very successful because it was a launch with a very less expenditure. And also it is far more successful beyond the expectations. That is, initially we planned the Mars Orbiter mission to work only for 6 months, but it had a journey of much greater duration than that and completed its lifespan in the year 2022. Now, because the Mars Orbiter mission or the first Mangalyaan mission completed its lifespan, we need a successor to that. That is the second Mars Orbiter mission, Mars Orbiter Mission 2 or the Mars 2. This Mars Orbiter Mission 2 was originally conceived, means originally we planned this mission to be an only orbiter mission. But now later we extended the plan to also include a lander, rover and a helicopter. Let us see what do we mean by these words. Let us imagine if this is the planet called Mars and you imagine this is an orbit around Mars, and then an orbiter will orbit around the Mars. It will not land onto the Mars surface. It will keep orbiting around the Mars in an orbit at an altitude above the Mars. And then the second component will be a lander. Lander will land onto the Mars. From that, another small component will get separated that will have wheels, a wheeled vehicle-like structure. We call that one as a rover. Rover is not only touching the Mars surface, it will also move on the Mars surface for a little distance beyond the landing site. Reason is, if we confine to the landing site and search for the resources on the Mars, we may have certain resources on the Mars, but we may not have them on the landing site. So we cannot just confine to a particular landing site. It is always better to move a little beyond the landing site and collect the sample from different areas on the Mars surface. So for that reason, the rover will walk or move on the Mars surface and will collect the sample, the soil sample from the Mars surface from different locations, not only from the landing site. And then there will be another structure called as a helicopter. This is nothing but a drone. This drone will try to fly in the thin atmosphere of the Mars. The Mars atmosphere is approximately 100 times thinner. It means 100 times less dense when compared to the Earth's atmosphere. So we have to check whether we can fly a helicopter or a drone in the thin Mars atmosphere. So initially we planned the Mars Orbiter Mission 2, MOM-2, to include only the orbiter. But later we extended the plan, and this is a more ambitious plan to include a lander, rover, and also the helicopter. This is how the plan got extended. Yes, the rover is like the lunar rover Pragyan. I hope this is clear for all of you. Right. Now let us see a few more key details about the Mars Orbiter Mission 2. Before we proceed with the key details of the Mars Orbiter Mission 2, please answer this question. The first Mangalyaan mission, which completed its lifespan in 2022, was it also a orbiter, lander, rover, helicopter, or only an orbiter? The first Mangalyaan was only an orbiter or includes the other components? No. Yes, Shira, correct. No, it includes only the orbiter. But MOM-2 is a more ambitious mission to include orbiter, lander, rover, and also a helicopter. Now let us see some key details. First, who is the operator? It means which space agency is going to operate this Mars Orbiter Mission 2? Obviously, it is ISRO. And what is the launch vehicle? Launch vehicle is nothing but the rocket. In which rocket we are planning to send the Mars Orbiter Mission 2, MOM-2. Likely, that is most probably, this is going to be LVM-3. LVM-3 means launch vehicle Mark 3, LVM-3. Previously, this LVM-3 was called as GSLV Mark 3. But the name is changed because the name GSLV Mark 3 gives us an impression that it is a rocket, it may launch the satellite only into the geosynchronous orbit. But the GSLV can also launch the satellites into a Martian orbit, lunar orbit, or the low Earth orbit, and many other different types of orbits. So the name GSLV Mark 3, that is Geosynchronous Launch Vehicle Mark 3, is not very much justified. So therefore they have changed the name to LVM-3. We also call this as the fat boy of ISRO or the Bahubali of ISRO. It is currently the heaviest vehicle that ISRO possesses. So most probably MOM-2 also will be launched in this LVM-3, right? Next, what will be the launch timeline? Because this all session is about future missions of ISRO. This is also a future mission, and the scheduled date will be somewhere between 2028 and 2030. So this class is current affairs and beyond. I mean, okay, in 2030 also these topics will be relevant. So this class is going to be a very, very important session. Okay. Then, so the tentative timeline will be the scheduled launch somewhere between 2028 and 2030. And what are the main objectives of MOM2? What is the target? Why are we sending this MOM2? To conduct more detailed studies. Why are we saying more detailed studies? Because MOM already completed some studies on the Mars. So now the target is to perform more detailed studies. On what? We want to study the Mars atmosphere, which I already told you approximately 100 times less dense or thinner when compared to the Earth's atmosphere. We want to study Mars atmosphere, Mars climate, and also the Martian surface. That is, we want to collect a sample from the Martian surface and we want to do the chemical analysis on that soil. We want to know the chemical composition of the Martian soil. These are the main objectives of MOM2. The approximate weight of MOM2 is going to be around 4,500 kgs. It is going to be a very heavier spacecraft. Okay. Now let us see what are the components of the mission. The components of the mission, I already explained briefly that it is going to have an orbiter which will orbit around the Mars, and a lander which will touch the Martian surface, and a rover which will walk on the Martian surface, and a helicopter or a drone that will fly in the Martian surface. But let us see the components a little bit more in detail. Okay, let us see the components more in detail. Okay, right. Now, it means rockets launcher's name are associated with the purpose of the mission. No, Chirag. Launcher or the rocket is nothing but the vehicle which is carrying the spacecraft. Here the spacecraft name is MOM2, and the vehicle which will carry this MOM2, the vehicle, launch vehicle, launcher, okay, rocket. Launch vehicle, launcher, rocket. All the three mean the same, that is going to be LVM3, Launch Vehicle Mark 3. Chirag, I hope it is clear. And the components briefly I already explained. Let us see about the components more in detail. The first one, okay, the cruise stage of the mission. The first stage of MOM2 is going to be the cruise stage. This is responsible for powering. Let us suppose you are driving your bike. Your bike needs an engine, that is to power the movement, fuel. Okay, so the cruise stage include powering, that is engine and the fuel in that, and then navigating. What more you want if you are driving a bike? You need the bike engine and the fuel in that. Same way, this MOM2 also need an engine and the fuel in that. This engine and the fuel inside the engine are the parts of which component or which stage? The cruise stage contain powering, that is fuel, and navigation. What else you want? You want route, directions. I mean, you have to know where to go, how to reach the Martian orbit. Navigation to the spacecraft during the long journey through the space. That is, when the MOM, say this is Earth surface, MOM2 will be launched from the Earth surface. Now it should reach the Mars and Mars orbit. It should reach the Mars orbit. Through this long journey, there is a very long journey in between. Through this long journey, we need powering and also we need navigation. Which stage will provide that powering and navigation during the long journey through the space? Cruise stage. The cruise stage contain engines which contain the fuel, because I told you powering is needed. So the cruise stage contain the engines. And solar panels. What the solar panels will do? They harvest the solar energy and convert it into electrical energy. We already have engines. The engines contain the fuel. Then why again solar panels? We cannot carry enough fuel because it's a very long journey. When it is a very long journey, you need a lot of fuel. So we cannot carry that much fuel in the LVM-3 that we have, because that is the heaviest vehicle that ISRO possesses, but it is not a very heavy vehicle on its own. So because it cannot carry sufficient fuel, it is also needed to harvest the solar energy and convert it into electrical energy. For that purpose, we need solar panels. And then communication systems. Okay, the MOM-2 during its journey should communicate with whom? The MOM-2 during its journey should communicate with the ground station which is located on the earth. We should be capable of communicating with the MOM-2 during its journey to provide its navigation and the other details. That communication systems also are present in the cruise stage itself. Also, the cruise stage contain the other support equipment. So the cruise stage contain engines containing the fuel plus solar panels to provide extra energy in the form of electrical energy, and communication systems that can communicate with the ground station on the earth, and other support equipment. All these things, on the whole, the cruise stage will help the MOM-2 in cruising, in traveling till the Mars. It is needed to keep the mission on track during its journey from the Earth to Mars. That is the cruise stage. Okay, so cruise stage is here. What is the cruise stage? Earth to Mars journey is called as cruise stage. What is the second stage? Descent stage. Okay, descent stage. What is descent stage? After the cruise stage, the MOM-2 is in the Mars orbit. And now descent stage means what? Like this. It should descend towards. All of you tell me, the MOM-2 after reaching the Mars orbit, that is after completing the cruise stage, it should descend towards what? Yes, everybody? It should descend towards the Mars surface. It should descend towards the Mars surface. Very good. Okay. So, the descent stage separates. The descent stage separates from the cruise stage. Once the MOM-2 is in the orbit, the descent stage will separate. Okay, let us suppose, imagine this pen. This is the cruise stage. This is the descent stage. They both will reach the Mars surface. Then the descent stage will separate from the cruise stage and will start descending down. Okay, and plunge straight into the Mars atmosphere without first orbiting the planet. See, I told you that it is not only an orbiter. Okay, very clear. You all already told me that. It is not only an orbiter. Very good. But even if you leave the word only, it is not at all an orbiter. It is not orbiting the Mars. It will directly, first it will reach the Mars orbit, and then directly it will descend down the Mars atmosphere without orbiting. Okay, if you observe here, it will not orbit around the Mars like this. Okay, so if you correctly understood this, all of you tell me, the first stage, cruise stage, is from Earth to the Mars. After the cruise stage, once the MOM-2 is in the Mars orbit, will the MOM-2 orbit around the Mars like this, or it will directly start descending towards the Mars surface for the landing purpose? Yes, everybody? Will it orbit around the Mars or directly descend towards the Mars surface? Yes, it will directly descend. Okay, if you observe this word, without orbiting the Mars surface, it will plunge straight into the atmosphere without first orbiting the planet, and that is called descent stage. Okay, after descent stage, as the descent stage enters the thin Mars atmosphere, which is 100 times thinner than the Earth's atmosphere, it will face the 7 minutes of terror. Use the word once, message me that word, 7 minutes of terror. What is the 7 minutes of terror? Okay, that is the travel through the Mars atmosphere. It will take 7 minutes, and why this is called the 7 minutes of terror? Because here you will have very high chance of failure. Why very high chance of failure? Because here the spacecraft experience friction. Because it is traveling through the Mars atmosphere, it will experience friction. The friction causes heat. The heat can damage the spacecraft. So it is called as the 7 minutes of terror due to intense heat and the high speed. Okay, why high speed? Because of the gravity. Because of the gravity, the speed increases, and the atmosphere will provide resistance. This will cause friction. Friction will generate a large amount of heat. That too, when it is traveling at a very high speed, the heat generated also will be very high. So therefore, it is having a very high chance of failure at this stage, means it is a very critical stage. NASA calls this particular stage as the 7 minutes of terror. After crossing this 7 minutes of terror, after passing through the Mars atmosphere, then the landing process begins. The landing process, yes, kind of turbulence. Okay, correct Padayachi. Okay, after crossing the atmosphere, the landing sequence will begin. The landing sequence includes aerobraking. Aerobraking, use the word aerobraking. B-R-A-K-E, brake means slow down. We use cycle brakes, brakes in the bike, brakes in the car. What they will do? They will slow down your car, or if needed, they will even stop it. This is aerobraking. Aerobraking means slowing down due to air. Air will be there in the atmosphere. Aerobraking, to slow down the spacecraft using atmospheric drag. First, what will slow down this particular? Why it should slow down? Because if it lands onto the Mars with high speed, it will crash land onto the Mars surface. So it should slowly land onto the Mars surface. For that reason, okay, after this 7 minutes of terror, it should slow down. That slowing down process is called aerobraking. That is because of the atmospheric drag. It is followed by deployment of the supersonic parachutes. Okay, supersonic means what? The word supersonic means faster than sound. Anything which is traveling faster than the sound is called a supersonic. Supersonic parachutes means the parachutes that can slow down the MOM-2 from its supersonic speeds. It will control those supersonic speeds. It will slow down the MOM-2. And then heat resistant aero shell. Okay, the MOM-2 need a shell around that. For example, if this is MOM-2, you need a shell around that. because otherwise the heat generated will melt it down. The aeroshell, okay, will be released to further reduce the speed and shield the lander. Okay, I'll tell you the steps here. Say first the cruise stage. Is it clear? First, cruise stage. Earth to Mars. This is the orbit. Okay. The first stage is called as cruise. Okay. And then now the Mars orbiter mission is here. MOM 2. Okay. And it will not orbit the Mars. Okay. MOM 2 do not orbit the Mars. Okay. Then after that what happens? It will directly land towards the Mars. That is descent. We use the word descent. Okay. During this descent phase, what all things will happen? First, aerobraking. The atmosphere will slow the MOM 2. Okay. Why? Because it should slowly touch the Mars surface. It should touch the Mars surface but slowly. Okay. It should slowly touch the Mars surface. Okay. So the aerobraking will slow this down. Atmospheric drag, that is a resistance to the atmosphere, will slow this down. And a parachute will be deployed. A supersonic parachute will be deployed. Parachute will further slow this down. And a heat resistant aeroshell will be deployed. Heat resistant aeroshell. It will protect the MOM 2 from the heat generated. And then finally, at an altitude of approximately 1.3 kilometers above the Martian atmosphere, when the MOM 2 is 1.3 kilometers above the Martian atmosphere, descent engines will ignite. Descent engines will ignite. Okay. Descent engines will ignite and they will carefully control the landing process. Okay, they will slowly, safely land the MOM 2 onto the Martian surface and carefully control the final approach, guiding the lander to a safe and precise touchdown. This is the order of the events. Is it clear? Okay, right. Then after it reaches the surface, then the next stage, the third stage is like cruise stage number 1 and then descent stage number 2 and then rover stage number 3. Okay, and number 4 is nothing but the helicopter, or we call this as drone. Okay, right. So now helicopter. This is inspired by NASA's successful Ingenuity drone. Is ISRO the first spacecraft to send a drone or a helicopter to Mars? No. NASA already sent a helicopter or a drone and flew this successfully in the Martian atmosphere. With that inspiration, we are also sending this drone. And NASA's drone is called as Ingenuity drone. And MOM 2 contains a helicopter which is inspired by the Ingenuity drone. This rotor craft will enable India to explore the Martian terrain from the air. It means while flying, okay, it will fly in the Martian atmosphere. The helicopter will fly in the Martian atmosphere and from the air it will study the Martian surface. Okay, this rotor craft will enable India to explore the Martian terrain from the air and extend our scientific reach beyond the immediate landing site. What is the advantage of the rover? Okay, rover will kind of study beyond the landing site. Beyond the landing site, but it has got a few limitations because it cannot fly. A drone can cover more surface area. So if you want to study larger surface beyond the landing site, you need this rotor craft called drone. It will survey the landscape, assist the navigation, and potentially scout. Scout means search. It will potentially search the locations for future missions. I mean, if you want to send Mom 3, Mom 4, where the Mom 3, Mom 4 should land, it will also search suitable locations for the future missions to Mars. Is it clear? I hope everything is clear for all of you. Next, now let us see what all payloads are included in this. Payloads means what? These are nothing but the instruments. What instruments are carried in the MOM 2? Instruments in MOM 2. Okay. The first one is Mars Orbit Dust Experiment called as MODEX. The first instrument name is MODEX. Its purpose is to study the origin, abundance and distribution of the Martian dust. Okay. In the Mars atmosphere we have dust. How this dust is originated, how much dust you have in the Mars surface, and how this dust change in different seasons, seasonal variations of the Martian dust. Not only the Martian dust, it will also do this kind of survey for the interplanetary dust particles, that is dust between the planets. That instrument is called as MODEX. MODEX will study about the Martian dust and interplanetary dust, about how that dust is originated and abundance, that is how much dust you have, and also what are the seasonal variations in that dust. Next one is called as radio occultation experiment. Radio occultation experiment. Okay, what is this? This is an instrument which is a microwave transmitter. Then you may get it out, what is microwaves? For that we have to see this electromagnetic spectrum. Electromagnetic spectrum contains different types of electromagnetic waves, and every wave will have peak, also called as a crest, and a trough. Crest and trough. The distance between two peaks or two crests, or the distance between two troughs, is called as wavelength. Wavelength is nothing but the distance between two crests or two troughs. And then frequency. Frequency is nothing but the number of crests or troughs that pass a given point per unit time. Okay, a given point per unit time. Okay, let us suppose if you have a wave like this, okay, and a given point here, okay, and second wave is like this, and you have that given point here, okay, that given point here, okay. So now tell me the first wave A or the second wave B, in which case more crests or troughs will pass through this point per 1 second. In which case more crests or troughs will pass through this point per second. Yes, it is B. So for this wave you have high frequency. Frequency is more because more crests or troughs will pass through the given point per second. But for this wave, the wavelength is more. Wavelength is more. and if the wavelength increases, the frequency decreases. They both are inversely proportional. Is it clear? In the electromagnetic spectrum, the waves with longer wavelength, look at here, are called as radio waves. Radio waves. We use these radio waves in our mobile phones and in our Wi-Fi and also in our radars. Radars. Is it clear? In the defense technology, in all those things we use radio waves. Then microwaves. Microwaves have little less frequency. Okay, I mean little more frequency, more frequency and low wavelength. Okay, it means they are little more faster than that. We use them for cooking purpose. Okay, infrared rays, their frequency is even more frequency, low wavelength. Okay, infrared rays. Is it clear? We use them in TV remotes. We use infrared waves in TV remotes. Then visible light. Visible light is nothing but the Vibgyor, different colors of light that we see. And then we have UV. If you observe, the UV radiations are very high frequency when compared to, look at the frequency here. Okay, and look at the frequency here. Very high frequency or very short wavelength, less wavelength, more frequency when compared to radio waves. X-rays are more higher frequency or less wavelength. Gamma rays are highest frequency. It means they are the sharpest. Okay, means they have very high efficiency of penetrating capacity. Okay, and high frequency and very low wavelength. Okay, and radio waves are opposite. Okay, more wavelength, low frequency or low energy and low penetration capacity. We use X-rays to take images during the fractures and all. Okay, during medical purpose we use, that is in the X-rays and CT scans. And we use gamma rays in the cancer treatment. In the cancer treatment also we use gamma rays. This is briefly about the electromagnetic spectrum. Okay, now what is this radio occultation experiment, RO instrument? This is an instrument which is working in the microwave frequency. Okay, it will send the microwaves. RO instrument, it will send the microwaves. Okay, in the X band, it will send microwaves in X band. Okay, and X band means what? Look at here, this is X band. X band is every band is nothing but, a band is nothing but a range of frequencies. A band is nothing but a range of frequencies. So X band is nothing but a frequency between 8 to 12 gigahertz of the frequency. Okay, microwaves in the X band frequency. Is it clear? Okay, and they can help, and what they will do? They will hit the Mars surface. Okay, radio occultation experiment, RO instrument. It will send the microwaves. It will send microwaves in which frequency? X band frequency. X band frequency means what? Okay, 8 to 12 gigahertz frequency. Those microwaves will touch the Mars surface. Mars surface. And then, okay, now what they will do is occultation. Use the word occultation once. Occultation means, okay, it will study, this RO instrument studies how the Mars atmosphere bends, is it clear? Okay, or refracts, refracts, okay, the microwaves. Is it clear? This radio occultation experiment, that is the name of the instrument. Okay, all of you tell me, what is radio occultation experiment? It is the name of a, everybody please, radio occultation experiment. It is the name of an instrument, right? We are using an abbreviation RO, that will emit the microwaves in the X-band frequency. They will touch the Mars surface, and the instrument will study how the Mars atmosphere is bending these microwaves or refracting these microwaves. This bending or refraction is nothing but occultation. You may get it out. What is occultation? Occultation is nothing but refraction or bending. Is that clear? The next instrument is energetic ion spectrometer. That is a third instrument. It will study the solar energy particles. Solar energy particles means these are the high energy particles, okay, coming out of the sun's corona. Sun's corona. Corona means what? The outer layer of sun's atmosphere. Outer layer of the sun's atmosphere. Okay. So, energetic ion spectrometer instrument will study the solar energy particles, which is also called as solar wind. Okay. It means the sun's particles. See, if this is the Mars and if this is the sun, and imagine this is the corona, that is the outer layer of the sun's atmosphere. From here, high energy particles are coming. High energy particles are coming, and this instrument EIS will study them. Then next instrument is, okay, J. So indirectly we are studying the optical density of the Mars atmosphere. Yes, J, correct. You are correct. Okay. The fourth instrument is nothing but Langmuir probe. Okay, and electric field experiment LPEX. This will estimate the plasma density and its variations. First, what is plasma? Plasma is the fourth state of matter. It means we have solid, liquid, gas. These are the three states of matter. It is the fourth state of the matter. It is very hot, super hot, and highly ionized. Super hot and highly ionized. This Langmuir probe and LPEX, these two instruments will measure how much plasma you have in the Martian atmosphere. Okay, plasma density, how much plasma you have in the Martian atmosphere, and how this plasma density is changing over a period of time. It means, is this plasma density increasing or decreasing? Okay, this instrument will study that. Okay, I hope everything is clear. With that, we completed the MOM-2, that is Mars Orbiter 2. Okay. Now, so a quick recap of Mars 2, Mars Orbiter Mission 2. Okay. It will have 4 components in that. That is the cruise stage that will travel from the Earth to the Mars, and then descent stage that will slowly descend onto the Mars surface, and a rover which will collect the Mars samples from the sites nearby the landing site, and a helicopter which will do the aerial survey of the Mars surface, and it will also search sites for the landing of the future Mars missions. These are the components. Initially we planned the MOM-2 to be only an orbiter, but later it became a more ambitious mission to include all these things. And the helicopter in our MOM-2 is inspired by Dash helicopter of NASA. Can anybody tell me? The helicopter in our Mars 2 is inspired by dash helicopter of NASA. Ingenuity helicopter. Okay. So is ISRO the first space agency to send a lander, rover, helicopter onto the Mars? Is ISRO the first space agency to send a lander, helicopter and rover onto the Mars? No. Okay. And then payloads. Mars Orbit Dust Experiment MODEX instrument will study about the Martian dust and interplanetary dust. Radio occultation experiment RO instrument will study how the Martian atmosphere will bend or refract the microwaves emitted by this instrument. Okay, it means it will study the optical activity of the Martian atmosphere. Okay, and then energetic ion spectrometer EIS will study about the high energy particles coming from the sun's corona towards the Mars. That is, it will study the solar winds. You know that solar winds will cause solar storms. We experienced solar storms on the earth. You know, the aurora, the beautiful northern lights or the polar lights are also because of the solar storms. So do Mars also get solar storms? That will be the function of this EIS. And finally, the Langmuir probe will study the plasma density and the changes in the plasma density. These are the instruments in the Mars Orbiter mission 2. Okay. Now moving on to the next one, that is Chandrayaan 4. Again, just like MOM 2 is a successor of MOM, Chandrayaan 4 is a successor to Chandrayaan 3. And Chandrayaan 3 was also a very big success. Also, it made ISRO the first space agency in the world, or India the first country in the world to make a soft landing on the South Pole. Okay. So, look at here. If this is the moon, this is the north pole of the moon, and this is the south pole of the moon. And if you have the earth here, okay, this part is called as the near side of the moon, and this part is called as the far side of the moon. Far side is also called as dark side of the moon. This is called dark side not because it is dark, not because there is no light. It is called the dark side because we do not know much about this side. Just like dark matter. What is dark matter? The matter about which we don't know. So dark side means what? The side about which we do not know. The earth facing side is called as the near side of the moon. Okay. It means if the moon is like this side is called near side. This side is called far side. Okay. So if you just observe like this, if this is the moon, this side is called near side, right side. Left side is called far side. Top is north pole, bottom is south pole. Okay. In this, there are two regions on the moon which are not much explored. The south pole is also unexplored. Unexplored. It means we do not know much about the south pole. Also, we do not know much about the far side. Okay. And our Chandrayaan 3. Okay, our Chandrayaan 3 was the first mission to make a soft landing on the south pole of the moon, not the far side, south pole of the moon. Is it clear? That is about the Chandrayaan 3. Okay, and Chandrayaan 3 also contained the lander, okay, 3 components, okay, propulsion module, propulsion module. Propulsion module means it will carry, like the cruise stage, it will carry from the earth to the moon. Is it clear? It will carry the Chandrayaan 3 from the earth to the moon. And then lander module, the lander module will make a soft landing. Okay, soft landing on the South Pole. And a rover, okay, that will walk on the moon. Is it clear? A rover that will walk on the moon. These are the 3 components of Chandrayaan 3. Okay, but our topic now is not Chandrayaan 3. Our topic is now Chandrayaan 4. What modules will be there in the Chandrayaan 4? First, propulsion module. So all of you tell me the propulsion module function. What is the function of the propulsion module? It will carry the Chandrayaan 4 from the earth to the moon. Is it clear? From the earth to the moon. Clear? Okay, if this is earth and this is moon, okay, the propulsion module will carry it like this. Propulsion. Orbit. Okay, earth, from the earth to the moon. Propulsion module. Okay, and then the next one, descender module. Okay, descender module, what it will do? This is the second one, descender. Descender will descend on to the moon surface. Okay, lands on the moon and collect the samples using a robotic drill and scoop. Drill will dig the moon surface. Scoop, like a spoon, will collect the moon soil. Is it clear? Okay, and then, okay, so tell me, did we collect, okay, any lunar soil, and did we bring any lunar soil back to the earth in our Chandrayaan 1, 2, 3? Did we bring the lunar soil onto the earth in our Chandrayaan 1, 2, 3? No, but okay, this will be a sample return mission. Chandrayaan 4 is a sample return mission. I mean, it will bring the sample. It will bring the sample to the earth. It will bring the sample to the earth, lunar soil sample to the earth. Why should we bring the lunar soil to the earth? Because on the earth we have bigger laboratories, more sophisticated laboratories. We have bigger and more sophisticated instruments. So we can do more detailed study on the earth. So it is important to bring the lunar soil onto the earth. Okay. So Chandrayaan 4 is going to be a sample return mission. Okay. So descender mission, what it will do? Lands on the moon and collect the sample. How does it collect the sample? Using a robotic drill and a scoop. Okay, collected the sample. And then what it is supposed to do? Ascender module. Okay, look at here. Ascender module will be like this. Did you understand? That is called ascender module. Okay, it means it will just observe the arrow marks. Ascender module is coming from the moon surface to the orbit. Descender module will go from the orbit to the moon's surface. I mean the descender module will land and also collect the sample. Is it clear? Descender module will land and collect the sample. Ascender module will bring the sample to the orbit. It will bring the sample to the orbit. Look at here. It lifts off from the lunar surface with the collected sample. It again lifts off. Look at here. It will again lift off. Okay. Again takes off or lifts off to the lunar orbit with the collected sample. Who collected the sample? Descender module collected the sample. Descender module collected the sample. Ascender module will lift off with the sample and bring it to the orbit. Okay. Then next one, transfer module. Use the word once. Message me this word. Transfer module. Okay. Transfer module, and the next one is re-entry module. Is it clear? Look at here. What is re-entry module? Okay. Look at this. Re-entry module is like another mission that we will send to the moon's orbit. This is called re-entry module. Is it clear? That is called as re-entry module. Okay. Why that is called re-entry module? It will go from the earth to the moon and again moon to the earth. It will come back also. Is it clear? It will go there, come back. Why it will go there and come back? It will go there, take the sample which is collected by this lander and come back to the earth, so that on the earth we can leisurely analyze this sample. Is it clear? Okay. And then what the transfer module will do? Okay. Transfer module, it will do like this. Is transfer module. Okay. It will go from here till here. Not till there, till, yes, till this point. Okay. Transfer module will go from there till, just one second. Okay, that is the orbit. And then re-entry module. Okay, transfer module, what it will do is, look at this carefully. Transfer module will carry the ascender module from ascender module till okay, it will carry from the ascender module till this particular point, that is till the re-entry module. Okay, descender landed, collected the soil, ascender brought it to the orbit, and then a vehicle came to take this sample back to the earth. So transfer module will go from here till that vehicle which is going to take this sample to the earth. It will carry this till the re-entry module. It will carry this till the re-entry module. Look at here. It facilitates, okay, it facilitates maneuvers for the module's journey and docking. Docking means what? Okay, use the word docking. Docking means, for example, look at here. This pen is now docking into the cap. Docking means fixing like this. Docking, attaching like this. Okay. So what should attach? Okay. The re-entry module docks with the ascender module now. Okay. The re-entry module will, see, this is re-entry module. This is ascender module. Okay. Re-entry module from here, ascender module from here. You tell me, okay, which one is having the lunar soil now? Re-entry module or the ascender module? Which module is having the lunar soil? Yes, all of you? Re-entry module versus the ascender module. Which one is having the lunar soil? No, Chirag, ascender module. Okay, you missed some important point here. Step 1, what happened? The descender module, okay, descended onto the moon, isn't it? Look at the descender module. Descender module. Descender module descended onto the moon's surface, drilled the ground, scooped the soil. Okay, tell me which module collected the soil, everybody. Which module collected the soil? Which module collected the soil? Descender module collected the soil. Which module will lift off and take that soil? Okay, soil. Okay, which module will take off and take that soil till the orbit? Which module will take that soil till the orbit back? This one. Yes, all of you? Ascender module. Very good, Anushka. Ascender module will take it to the orbit, lunar orbit. Which orbit will hand over this particular soil to the re-entry vehicle? Which soil will take it till this re-entry vehicle? The green color line, if you observe, which will take this till the re-entry vehicle? That green color one is called as transfer module. The re-entry one, this green color one, it will take this particular sample till the re-entry vehicle, or it will carry this ascender module with the soil till the re-entry vehicle, and then re-entry vehicle and the ascender module will dock together. This ascender module will dock with the re-entry vehicle. Once the ascender module docks with the re-entry vehicle, the soil in the ascender module will go into the re-entry vehicle, and the re-entry vehicle will send that soil to the earth surface. This is the story. I hope it is clear. Okay, so this is how it works. Okay, so step 1, let us just have a small recap. Step 1, propulsion module will carry the Chandrayaan 4 till the lunar orbit. Then the lander will land onto the lunar surface, drill the ground and collect the sample. And the ascender module will bring that soil till the orbit, lunar orbit. Transfer module will carry this ascender module to the re-entry vehicle. Then the ascender module will dock with the re-entry vehicle, and the re-entry vehicle will bring that sample back onto the earth surface. On the earth surface, we can leisurely study about that soil. Ascender lifts off from the lunar surface with the collected samples. Transfer module facilitate the ascender module's journey and docking, and re-entry module docks with the ascender module in the lunar orbit, receives the sample and returns the sample to the earth. These are the 5 modules in the Chandrayaan 4, and it is going to be a sample return mission. It will bring the lunar sample onto the earth. And then orbital docking. I already explained what is orbital docking. In the orbit, 2 modules attaching with each other. In the orbit, 2 modules attaching with each other is called as orbital docking. This mission will demonstrate the docking capacity. Till now, Chandrayaan 4 is going to be a future mission. Till now, ISRO do not have the docking capacity. But very recently, January 2025, in the SpadeX mission, you might have heard about the SpadeX mission. SpadeX is nothing but Space Docking Experiment. Okay, Space Docking Experiment. It is an experiment. SpadeX mission was completed, already completed this year, January, in the month of January. So SpadeX mission demonstrated that we can dock two components in the orbit. We can attach two components in the orbit. Now the Chandrayaan 4 probably will be the first mission that will use this docking capacity. It means ISRO recently developed its docking capacity and demonstrated the docking capacity recently this year in the month of January in its prestigious SpadeX mission, and the first mission that is going to use this capacity probably will be Chandrayaan 4. For the docking of the re-entry module with the ascender module, it will use a docking capacity. Is that clear for all of you? Next, sample collection. The Chandrayaan 4 will utilize advanced robotic systems to collect and seal the sample and prevent the contamination. Okay, we are using advanced robotics to collect the sample and also prevent the contamination by properly sealing it. The robotic arm will collect the soil and seal it without getting contaminated. Okay, and this sample collection is done by which module? Yes, all of you. The sample collection is done by which module? Propulsion module, descent module, ascent module, transfer module, or re-entry module. Take it as a multiple choice. Everybody? Descender module, very good. Sample handling. A new specialized facility. It means on the earth we are constructing a new facility. I mean a new laboratory. It will be developed by ISRO to store and study these samples. Okay, we are building a laboratory on the earth. So to safely store and study the lunar sample which the Chandrayaan is going to bring. We are building a laboratory on the earth to safely store and study about the lunar soil which the Chandrayaan 4 is going to bring in the future. Okay, and Chandrayaan 4 is a critical precursor to the crewed lunar missions. I mean our Chandrayaan 6 and Chandrayaan 7 are going to be the crewed missions. I mean we are going to land astronauts onto the moon. We are going to land astronauts onto the moon, but not even in the Chandrayaan 5. Okay, Chandrayaan 6 and 7 are going to be manned missions to the moon. Okay, tell me which Chandrayaan we discussed till now? Chandrayaan 1, 2, 3 or 4 or 5? Which Chandrayaan mission we discussed till now? Chandrayaan 4. Is it just a orbiter or a lander or a sample return mission or a manned mission? Is Chandrayaan 4 just a orbiter or a lander or a sample return program or a manned mission? Sample return mission, very good. Chandrayaan 5, is it going to be a manned mission by ISRO? Are we going to send astronauts in the Chandrayaan 5? No. In Chandrayaan 6 and 7 we are going to send the astronauts onto the moon. Now that we completed the Chandrayaan 4 having propulsion module, descent module, ascent module, transfer module and re-entry module that will bring the soil, and we are also constructing the laboratory on the earth to safely store this sample and study that leisurely. Now that we completed about Chandrayaan 4, let us going to see about Chandrayaan 5. But interestingly, Chandrayaan 5 is not an exclusive mission by ISRO. It is a joint endeavor, that is a collaborative endeavor between India's ISRO and the Japanese space agency called JAXA. ISRO, JAXA both together are sending the Chandrayaan 5. Is it clear? So which two space agencies are sending the Chandrayaan 5? Everybody? Which two space agencies are sending the Chandrayaan 5? ISRO and JAXA. Chandrayaan 5 is also called as LUPEX mission. The other name of Chandrayaan 5 is LUPEX mission. What is LUPEX? Lunar, LU, okay, polar exploration, LUPEX, lunar polar exploration, because the main target of Chandrayaan 5 is to study the lunar poles. We want to particularly study the polar regions on the moon. Okay, so the Chandrayaan 5 is also called as LUPEX mission. India's National Space Commission approved the LUPEX mission, marking the country's 5th lunar mission. LUPEX mission is going to be the 5th lunar mission by ISRO, and as I already told you, it is a joint endeavor by ISRO and JAXA. It is aimed at exploring the moon's resources, particularly water and ice. Okay, what is the target of the LUPEX mission? Yes, all of you, what is the target of LUPEX mission? It will study the moon's resources. Okay, it will study all the resources, but most importantly, which resources LUPEX want to study? Most importantly, LUPEX wants to study whether we have water or not, whether we have water on the moon's surface or not. And particularly, LUPEX want to study, okay, whether you have water on the poles. Is it clear? In its polar regions, both on the surface and beneath the lunar regolith. Regolith means the topmost surface, on the moon. Okay, it is loose soil. Okay, it means not hard rock. Okay, hard rock will be at a little deeper layer. Above this we have some loose soil. That layer is called as regolith. Okay, so tell me, LUPEX wants to study resources. Particularly which resources? Water and ice. More particularly at which region? Poles. Okay, more particularly at which region? Poles. In the poles, it will study whether water is present or not. Will it study the presence of water only on the surface, or also it will drill and see whether you have water beneath the regolith? Okay, surface and regolith. What it will study? Resources. Which resource? Water. Where? Poles. On the poles, only the surface or beneath the surface? Beneath the surface. That is the target of LUPEX mission. I hope the LUPEX mission target is clear. Then, LUPEX is proposed to lift off in the year 27-28. But which country is going to launch the Chandrayaan 5? Is ISRO going to launch the Chandrayaan 5 or the LUPEX mission? No. A Japanese rocket called as H3. We have seen MOM 2 we are going to launch in LVM 3. Chandrayaan 4 we are going to launch in LVM 3. But Chandrayaan 5, the LUPEX mission, we are not launching in LVM 3. we are launching the Chandrayaan 5, that is LUPEX mission, in a Japanese rocket called as H3 rocket. Okay, it is designed, the LUPEX mission is designed to operate for 100 days. Okay, I mean the lifespan of the LUPEX mission is going to be 100 days. Okay, and it will study not only the poles, most importantly, it will study the far side of the moon. I already told you, far side of the moon means if this is the earth and this is the moon, okay, this side of the moon is called near side, this side is called as far side. Okay, LUPEX is going to be the first mission by ISRO that is going to study the far side of the moon. Okay, till now India did not launch any lunar mission onto the far side of the moon. Okay, South Pole we have done with Chandrayaan 3, but not the far side. So this LUPEX mission is going to be the first mission which is going to reach the far side of the moon. Not the first mission in the world, first mission of ISRO to reach the far side. Okay, China already explored the far side of the moon. Remember, Chinese mission already explored the far side of the moon. Okay, so it will also go to the far side of the moon towards the end of the mission. And if possible, we are also planning to extend the mission life by 1 year. Initially, we are planning the mission lifespan to be around 100 days. If possible, we are planning to extend the mission life by up to 1 year also. In the span of 1 year, it will study the presence of resources, more particularly water, particularly at the poles, near the poles, on the surface, plus also little beneath the regolith. Okay, and the lifespan is 100 days, extendable up to 1 year. And towards the end of the mission, the target is also to reach the far side of the moon. LUPEX mission will utilize advanced tools, and in this Japan will construct the rover and rocket while ISRO will develop the lander. Okay, in the LUPEX mission, what is the role of ISRO? ISRO will develop the lander. What is the role of JAXA? What is the role of JAXA? Okay, JAXA will provide the rocket. Which rocket? H3. And also JAXA will provide the rover, whereas lander is provided by ISRO. Okay, tell me, LUPEX mission or the Chandrayaan 5 is a joint endeavor by ISRO and JAXA. In this, which space agency provides the rocket and the rover? All of you please, which space agency provides the rocket and the rover? Yes, JAXA. Very good. Which space agency provides the lander? ISRO. Name the rocket in which we are sending the LUPEX mission. Name the rocket in which we are sending the LUPEX mission. H3 rocket. The LUPEX rover weight is 350 kgs compared to 26 kgs of Prelims rover of the Chandrayaan 3. We are sending the rover in the Chandrayaan 5 or LUPEX, but is it the first time ISRO is sending a rover onto the moon? No. We already sent rover in the Chandrayaan 2 also. Is it clear? In the Chandrayaan 3 also. That rover is called as Prelims rover. Weight of the Prelims rover is 26 kg. but the weight of the rover in the LUPEX mission is going to be 350 kg. It is much heavier rover in the Chandrayaan 5, that is LUPEX mission. Is it clear? Okay, and then significant scientific instruments in the Chandrayaan 5. Instruments in LUPEX mission or instruments in the Chandrayaan 5. Okay, the first mission is called as Resource Exploration Water Analyzer REWA. Resource Exploration Water Analyzer. The name itself is self-explanatory. Resource exploration. We are using this instrument to explore the resources. What resources are present in the lunar soil? More particularly, this REWA will analyze the presence of the water. Resource Exploration Water Analyzer REWA. This instrument is by JAXA. Which space agency provides this particular instrument? JAXA provides this REWA. But REWA is not a single instrument. REWA is like a package. It's a package of several instruments. It is an integrated package of multiple instruments. This integrated package of multiple instruments are for analyzing the drilled regolith samples. From the we drilled the regolith. If you remember, we have a robotic driller and scooper. It will drill the regolith and scoop out the sample. Now we have the sample. In that sample, it will analyze the presence of the resources and more particularly water. But REWA is not a single instrument, it is a package of instruments. It's a package of instruments. Then the second instrument by JAXA is Advanced Lunar Imaging Spectrometer. Okay, look at this word spectrometer. If you observe, break this word, the word meter means measure. What it will measure? The spectrum. What is the spectrum? The electromagnetic spectrum. And as you already know, the electromagnetic spectrum will have radio waves, microwaves, then you have IR, then you have visible, then you have UV, then you have X-rays, then you have gamma rays. Is it clear? And a spectrometer is an instrument that will measure. I have given the meaning here. Spectrometer definition. Spectrometer is an instrument that measures the properties of the light. Okay? Light or other radiation. Light means what? Visible light. We can see the light. Other radiation means what? Other radiations will be there? IR, microwaves or radio waves, etc. Okay? So spectrometer is an instrument that will measure the properties of the light waves or that will measure the properties of the other radiation. What properties it will measure? You tell me what properties will be there for the radiations in the electromagnetic spectrum. We will have wavelength, we have energy or frequency, and we have intensity. It means how much light is there, what is the frequency of the light, what is the wavelength of the light, intensity of the light, frequency of the light and wavelength of the light. Such properties will be measured by this instrument. Okay? It's an instrument that measures the properties of light. Will it measure the properties of only the light waves? No, it can also measure the properties of radio waves, microwaves, IR, visible, different radiations. Okay, by separating the component wavelengths. It means it will separate the radiation into different components. It means spectrometer will separate IR from micro, or microwaves from radio waves, like this: radio waves, microwaves, okay, IR, visible. It will separate them into different components, and it will measure. It will separate the components and then it will measure. What it will measure? Intensity, frequency, wavelength, like properties. Okay, so on the whole, spectrometer is an instrument that measures the properties of the light or other radiation by separating the spectrum into its component wavelengths to create a spectrum. That kind of an instrument is called as spectrometer. Okay, now for example, look at here. This one, advanced lunar imaging spectrometer. Okay, so we are using spectrometer here. It will measure the intensity, wavelength and energy of electromagnetic radiation. Okay, electromagnetic radiation. Is it clear? In the near IR range, near IR means what? I have given that meaning also here. Okay, what is near IR? Mid IR. Okay, these are the two regions of the infrared spectrum. Okay, near IR and the mid IR are the two regions in the infrared region, distinguished by their wavelengths. I mean, near IR and mid IR wavelengths will be different, with near IR closer to the visible light. Okay, it means if you observe this spectrum, look at this spectrum. Here you have visible. Okay, so this part is called near IR, and this part is called as mid IR. Mid IR. This part is called as far IR. What is near IR? Infrared rays which are closer to the visible light. Infrared rays which are closer to the visible light. Okay, it means from this you tell me, that means near IR is closer to the visible light. So it will have a high frequency or low frequency. Okay, far IR, mid IR, near IR. Which of these three will have a high frequency? All of you? Far IR, mid IR, near IR. Which one will have high frequency? Based on the information that the near IR is close to the visible light. Others, you can just guess. You can go wrong, no problem. Just guess it. Near IR will have high frequency because it is this side, close to this side. Okay, this side you have high frequency, left side you have low frequency waves. Please observe, in the spectrum, right side you have high frequency, gamma rays, X-rays, UV, all those things. Left side you have low frequency. Near IR is close to the visible, I mean towards the right side. So that is high frequency. Mid IR is going to be comparatively low frequency. Is that clear? Okay, so now if you come back to this, if you analyze it, what is this instrument? Observe it. It is a near IR imaging spectrometer. Okay, look at this. This is a near IR imaging spectrometer. Basically, what is a spectrometer? An instrument that will measure. Okay, read this. Basically, what is a spectrometer? An instrument that measures the intensity, wavelength, frequency of the electromagnetic radiation in general. Okay, if that is in general, now if you observe, this is a near IR. It means, okay, it will measure the intensity, wavelength or energy of the electromagnetic radiation. Which electromagnetic radiation? Near IR radiation. Means this is an instrument that will measure the intensity of near IR rays in the moon surface. Is it clear? Okay, I mean using the near IR imaging spectrometer for observing the water and OH on the surface and excavated regolith. Okay, so tell me, what is a spectrometer? It will measure. Spectro means spectrum, meter means measure. It will measure the electromagnetic waves. And then you have different types of spectrometer. For example, near IR spectrometer will measure the near IR rays. Mid IR spectrometer, UV spectrometer, visible spectrometer, like that we have different types of spectrometers. This particular spectrometer, okay, will measure the intensity of the IR radiations, infrared radiations. Okay, using this near IR radiations, okay, it will study the presence of water and the OH group on the surface and also in the excavated regolith of the moon. Okay, it means what? This instrument, okay, this instrument Alice will send, okay, near IR. They will touch the moon surface. Then the moon surface will reflect that near IR rays. Moon surface will reflect the near IR rays. And now this Alice will measure the intensity and other properties of the reflected near IR rays. Why it will study the properties of the reflected mid IR rays? To understand about the moon's surface. To understand about the moon's surface. That is called Alice. Okay. Then the next instruments are by ISRO. If you observe, they are the ISRO's instruments. Okay, JAXA's instruments. Okay, JAXA's instruments are completed. RIVA and Alice. RIVA is a resource analyzer and Alice is a spectrometer which will work in the range of near IR. Okay, I have given the meanings clearly here. There are two regions of the infrared spectrum distinguished by their wavelengths, with NIR being closer to visible light, MIR having longer wavelength. MIR longer wavelength, left side, near IR shorter wavelength or high frequency towards the right side. Okay, Tanu Varnal, is it clear? Okay, now, so ISRO's instruments now. ISRO will send a ground penetrating radar. Okay, what is a radar? Radar will emit the radio waves. Earlier the spectrometer emitted what rays? Near IR. Radar will emit the radio waves, these waves, not these waves, not the near IR, but it will emit the radio waves. Is it clear? Radar will emit the radio waves, and then the radio waves will touch the moon's surface. Not only touch the moon's surface, it will even go down. That is the reason why we call this as ground penetrating radar. Ground penetrating radar. Why? Because the radio waves will penetrate the moon's surface. Is it clear? Will penetrate the moon's surface, and then this moon's surface will reflect this radio waves back. And the radar will now analyze the reflected radio waves. Why? To understand the nature. To understand the nature of the moon's surface. Is it clear? This is how the ground penetrating radar works. Which space agency is providing this ground penetrating radar, which will scan the surface to a depth of 1.5 meters? How much depth it will penetrate? It will penetrate 1.5 meter deep under the ground. Ground penetrating radar that will penetrate the moon's surface up to 1.5 meter. This ground penetrating radar is provided by which space agency? Yes, all of you? Then very good, that is by ISRO. Then next one, the next instrument is Permittivity and Thermophysical Investigation for Moon's Aquatic Scout. Difficult to remember the name, just remember this as Pratima. So Pratima detects and quantifies water ice in the top 20 to 30 centimeters of the lunar surface. What is the role of Pratima? What Pratima will do? It will detect and measure the quantity. Two things. It will detect whether water is there or not. And if water is there, it will measure the quantity of the water. Up to what depth? Up to 30 centimeters of the lunar surface. Is it clear? And then mid-infrared spectrometer. Same thing. It will also measure. This is mid-infrared spectrometer. So it will measure the intensity, frequency, and other properties of mid-infrared rays. If it is UV spectrometer, then it will measure the intensity, frequency, and other properties of the UV rays. If it is a visible spectrometer, it will measure the intensity, frequency, and other properties of the visible rays. If it is a near IR spectrometer, it will measure the intensity, frequency, and other properties of the near IR rays. All spectrometers do the same, but they will work in different regions of the spectrum. Some of them will measure UV rays, some of them IR, near IR, some of them mid IR, some of them radio waves, like that. Is it clear? So mid IR spectrometer, this will also detect the presence of water and the OH group on the lunar surface. Is it clear? Next one, Raman spectrometer, that is a special type of a spectrometer. It will also measure the intensity and other properties of the electromagnetic rays. But this Raman spectrometer will not operate together. If you remember, I told you that JAXA's instrument called RIVA, I told you that it is not one instrument, rather it is a complete package. That package also includes, JAXA's RIVA package also include ISRO's Raman spectrometer. JAXA's RIVA package also include ISRO's Raman spectrometer. It is integrated in the RIVA package. I hope it is clear. So, with that we completed the instruments by JAXA and ISRO. But by the way, which spacecraft we are discussing? Okay, sometimes I will get the doubts like this, because as a student, when the teacher is teaching a topic, I used to sometimes forget what the teacher is teaching all about. Okay, so just tell me which topic we are discussing right now. Quick. Very good. LUPEX mission. What is the other name of LUPEX mission? What is the other name of LUPEX mission? Chandrayaan 5. Chandrayaan 5. Very good, Tanu. Okay. And is it a mission exclusively by ISRO or a joint venture? If it is a joint venture, it is a joint venture between which two space agencies? ISRO and JAXA. Very good. ISRO and JAXA. And in that, JAXA, ISRO provide their own instruments. Rocket, okay, and the rover by JAXA, lander by ISRO. Is it clear? And also ISRO and JAXA provided different instruments. In addition to ISRO and JAXA, other countries also, other space agencies also, look at here. This is NASA's instrument in the LUPEX. NASA's instrument in the LUPEX. It is neutron spectrometer. What it will do? It will observe the underground neutrons. It means it will observe the neutrons present underground the moon's surface. Underground the moon's surface. Why does this instrument measure the neutrons? By measuring the neutrons, it can understand the presence of hydrogen. If neutrons are present, means hydrogen. This indicate, presence of neutrons indicate the presence of hydrogen element. Okay? And NASA's neutron spectrometer will observe the neutrons under the ground. Under the ground, how deep, how much depth? 1 meter deep. 1 meter deep during the rover's travel. Okay? Say, for example, if this is the moon and rover. This rover is 350 kg rover by JAXA. While it is traveling, this neutron spectrometer, okay, will go up to 1 meter deep, okay, and it will search for the neutrons. While the rover is walking on the moon surface, NASA's instrument called neutron spectrometer, okay, will penetrate 1 meter deep, okay, and will search for the neutrons. If neutrons are present, means hydrogen is present. And lastly, we have another instrument by European Space Agency. European Space Agency provides an instrument called as exospheric mass spectrometer. This is also another type of spectrometer. it will study the exosphere of the moon. Okay, it will measure the near IR and mid IR, okay, radiations of the exosphere of the moon. Is it clear? With that, we completed the LoopX mission, that is Chandrayaan 5 completed. Okay, then I have given a few MCQs for you to solve. So solve this question and tell me. LoopX, that is Lunar Polar Exploration Mission, is a joint project between which two space agencies, A or B or C or D? Others also? Very simple question. Then you may ask me, do we get such simple questions in the UPSC exam? Yes, very much. Okay, many times we get very simple questions from science and technology. As simple as, in one of the previous years, they asked a question, qubits are used in. One of the multiple choice is quantum computer. Even a 5th class student will answer that. That is the advantage with science and technology, because they don't expect you to become a scientist. Very basic questions are asked several times and the answer is as you all suggested. This is D is the correct answer. Fine. After completing the Chandrayaan 5, what is the next mission after Chandrayaan 5? Chandrayaan 6. Chandrayaan 6 goal is to develop. Okay, see, these topics can be difficult. I agree, this is a bit too technical, but it will be useful for the next 2-3 years. Long term advantage with this topic. Okay, ISRO's roadmap for the future. You will keep on getting the news articles. In the newspapers, you are going to get articles on these topics in future. It means not current affairs. Future news articles we are discussing now. Okay. So what will be the goal of Chandrayaan 6? To develop the ability to use lunar resources for the construction, build the infrastructure and habitats on the moon. By Chandrayaan 6, we are planning to send astronauts onto the moon. Not only that, we want to build, okay, houses, habitats and infrastructure on the moon for the long-term stay on the moon. Okay, not just going there and coming back. So we are planning the long duration stay on the moon. Timeline will be mid-2030s. I mean somewhere in 2038, 2039. Okay, like that we can expect this mission. I hope it is clear. That is Chandrayaan 6. Okay, and Chandrayaan 7 mission. What the Chandrayaan 7 will do? Chandrayaan 7 goal, target. The target of Chandrayaan 7 is to establish lunar fuel stations. We want to establish fuel stations on the moon. Okay. We want to tap the lunar water resources. We want to use water present on the moon. By the way, which spacecraft got a world record for first time proving the presence of water on the moon? To be very proud, it was Chandrayaan 1. ISRO's Chandrayaan 1 got a world record, okay, for identifying the presence or proving the presence of water for the first time in the world. Okay. From Chandrayaan 1 onwards, we are constantly in search of water. Repeatedly we are identifying water. Repeatedly we are searching for the presence of water. We are searching for the presence of water on the North Pole, on the South Pole, on the near side, on the far side, on the surface, beneath the surface. Is it clear? Several spacecrafts by ISRO, several spacecrafts by the other space agencies. Why everybody is behind water? Because if we have to establish a long duration stay on the moon, if I have to stay there for 1 year, I need water for me to stay on the moon. So for the Chandrayaan 6 and Chandrayaan 7 to be possible, we definitely need water on the moon. So we are so curiously searching the presence of water on the moon. Okay, with the ultimate goal of supporting long-term human presence and facilitate advanced deep space missions. Interesting. What do you mean? Why do you want to stay on the moon? We have Earth na. Why long duration stay on the moon? Why long-term stay on the moon? Because we can plan interplanetary missions and solar missions. Solar missions from the moon. From the moon. Is it clear? It means, let us suppose this is Earth. This is moon. So first we will go to moon and then we will stay there for long duration stay, and then imagine this is the sun and we are planning to make launches from the moon. Is it clear? It means we are planning to do deep space. These are called deep space missions. What are the deep space missions? Okay, the solar mission, that is the missions that will cross our solar system. It means cross our interplanetary regions, far away from the Mars, far away from the Venus, and may go till the sun, or may study the other stars also. Like for example, you might have heard about Voyagers, Voyager 1 and Voyager 2. They entered into the interstellar space, that is space between the stars. Such missions are called as deep space missions, that is very far away missions. So why do you want to have a long-term human presence on the moon? Because we are planning to do some launches from the moon. Is it clear? Make a launch from the moon. A rocket will go from the moon to the sun, moon to the Mars, moon to the Venus, like that. Okay, for that reason we want to have a long-term stay on the moon. The timeline will be late 2030s, that is somewhere in 2038, like that. That is Chandrayaan 7. Is it clear? Tell me, in which Chandrayaan mission we are planning to do launches? We are planning to stay there so long that we construct a space agency there and we will do some launches from the moon. Which lunar mission we are planning to do launches from the moon? In which lunar mission we are planning to do launches from the moon? What will be the first lunar mission in which we are going to send astronauts onto the moon? What will be the first lunar mission in which we are going to send astronauts onto the moon? Chandrayaan 6, very good. Chandrayaan 6. 6 will be the first mission in which we send the astronauts. Look at here. Okay, we send astronauts, habitations also. Is it clear? It is going to be a manned mission. Okay. Then develop ability to use lunar resources, aiming to build infrastructure. How do you build infrastructure without sending the astronauts? But long-term duration, so long that you even you can plan launches from the moon in Chandrayaan 7. What will be the first ISRO's mission in which we are planning to study the far side of the moon? What is the first lunar mission by ISRO in which we are planning to study the far side of the moon? No, Chandrayaan 5 LUPEX. Chandrayaan 5 LUPEX will study. Look at here. Chandrayaan 5 LUPEX will study the far side of the moon. LUPEX mission, far side of the moon. Is it clear? Okay. In which mission we are going to first time return the sample from the moon? In which mission first time we are planning to return the sample from the moon? Sample return. Chandrayaan 4 is also sample return. Is it clear? Chandrayaan 4 is going to be a sample return. Let us consolidate. Chandrayaan 4, okay. Start from Chandrayaan 3. Chandrayaan 3, South Pole soft landing. Chandrayaan 4, sample return. It means collecting the lunar sample and bringing it onto the earth. Chandrayaan 5 or LUPEX, far side. Okay. Chandrayaan 6, first manned mission. Chandrayaan 7, long duration stay, so long that we can even launch missions from the moon. I hope it is clear for all of you. Right. Okay. Then, so with this we completed these mooned missions. Okay, yes, 3 South Pole, 4 sample return, 5 far side, 6 first manned mission. Second one, long duration stay on the moon. Not only that, we are also planning not only missions to the moon. Till 7, okay, look at here. Till Chandrayaan 6, it is missions to the moon, but Chandrayaan 7 is even the missions from the moon. Is it clear? Okay, so that is the difference. Then the next project by ISRO, and I remind you the topic we are discussing for the people who joined late. The topic we are discussing is ISRO's roadmap for the future. That is some future missions or projects by ISRO. Till now we completed Mars Orbiter mission MOM2, and then Chandrayaan 4, Chandrayaan 5, Chandrayaan 6, Chandrayaan 7. Chandrayaan 5 also being called as LUPEX. And the sixth topic we are discussing in today's class is not a spacecraft. We are going to discuss about a new type of the rocket. We call this rocket as the new generation launch vehicle. NGLV means what? New generation launch vehicle. New generation launch vehicle, NGNV. Okay, or next generation, NGLV, or next generation launch vehicle, NGLV. Okay, the new generation launch vehicle or NGLV, which was previously called as ULV. Tell me what was the previous name of new generation or next generation launch vehicle? All of you. The former name of new generation launch vehicle. The former name of new generation launch vehicle, ULV. ULV stands for Unified Launch Vehicle. And why do we call this as Unified Launch Vehicle? because this one single launch vehicle is planned to replace our PSLV, Polar Satellite Launch Vehicle, our GSLV, okay, Geosynchronous Satellite Launch Vehicle, and our LVM-3, that is GSLV Mark III. We have different rockets like this. Is it clear? PSLV, PSLV Core Alone, PSLV XL, PSLV DL, like that we have different variants of PSLV. We have GSLV Mark II, GSLV Mark III, like that we have different variants of GSLV. So one rocket that is going to replace all these rockets, therefore it is called as a unified launch vehicle. But later it is renamed as the new generation launch vehicle. This is going to be a 3-stage launch vehicle. What do you mean by these stages? Most of the rockets will have multiple stages. Okay, here this NGLV is having 3 stages. Is it clear? Okay, stage 1. Stage 1 will be ignited during the launch on the ground. Is it clear? On the ground during the launch, we ignite the stage 1. Now, the stage 1 will keep on burning like this. It will burn, 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 burn. By the time the stage 1 is completely burnt, the burnt stage 1 will ignite the stage 2. The burnt stage 1 will ignite the stage 2. Then same way the stage 2 will burn, burn, burn. Once the stage 2 is completely burnt, the burnt stage 2 will ignite the stage 3. Stage 1 will be ignited on the ground. Stage 2 and 3 will be ignited during the journey in the space. Usually, the first stage will fall back to the ground. The first stage will fall back to the ground. The later stages will become the space debris. The later stages will become the space debris. You might have heard about the space debris. Small bits, okay, pieces will keep orbiting the earth at a very high speed like bullets, like shrapnel. They are called as space debris. And we have problem with the space debris that these fragments can even hit the other rockets or other spacecrafts and damage the other satellites or wound or injure the astronauts. Is it clear? So, you might have already studied about the problems by space debris. If we do not take special efforts to reduce the space debris, future space missions will become impossible. We cannot launch any more satellites in the future if we do not decrease the formation of the space debris. Okay, leave about the space debris. NGLV, the new generation or the next generation launch vehicle, formerly called as Unified Launch Vehicle, will have 3 stages. Okay, and in these 3 stages, the first stage is solid, second stage is liquid, and the third stage is cryogenic. The first stage is called a solid stage. It means what? A solid stage means it will use solid fuel. In general, solid fuel has one advantage. The advantage is it will give the greater thrust. Greater thrust means greater push. but it is also having a disadvantage. Okay, disadvantage, that is, okay, we cannot switch on and switch off. Is it clear? It means once ignited, it will completely burn. So usually we keep the first stages as solid stages. Why? Because first stage we are igniting on the ground. On the ground there will be a greater influence of the gravitational force. So now the spacecraft should overcome the influence of the gravitational force. So that is the reason why it needs a greater thrust, which cannot be provided by the liquid stage. The second stage is a liquid stage. It will use liquid fuel. Here the advantages and disadvantages are just opposite. It means a liquid fuel. Okay. Santosh, yes, SSLV and NGLV are very different. Okay. If you want, let me explain those differences also. See, first we have SLV, that is satellite launch vehicle. Next you have ASLV, that is augmented satellite launch vehicle. Next you have PSLV, that is polar satellite launch vehicle. Okay. And next you have GSLV, that is geosynchronous satellite launch vehicle, and this is also called as LVM. Okay. Next you have SSLV. Okay. SSLV means small satellite launch vehicle. Small satellite launch vehicle. Okay. These are the vehicles that we already have. These are the vehicles that we already have. Now RLV. RLV means relaunch vehicle. Relaunch vehicle. It means a vehicle that we can repeatedly use. We will send one spacecraft, it will go launch it, come back. Again you can use it. Again you can use it, like that. This is the relaunch vehicle. So all of you just guess and tell me, it means SSLV, ASLV, PSLV, GSLV, SSLV, all these are use and throw vehicles. Do you agree with me? RLV is the first relaunch vehicle. It means all the earlier vehicles that we have are single use. We launch, then it's gone, it will not come back. Okay, its pieces may fall down, but it will not come back in its functional condition so that we can do another launch with that. All the earlier ones are single use. Is it clear? And this one is under development. We still do not have a relaunch vehicle. This is still under development. Is it clear? And the next one is NGLV. NGLV is going to be the heaviest vehicle. Heaviest vehicle, okay, by ISRO. This is not even under development. That means it is the future planned vehicle. This is the future planned vehicle. Okay. RLV is under the development. Okay. And NGLV is future vehicle, and it is going to be a heaviest, and SSLV is going to be the lightest. Why did we make lightest vehicle after GSLV? Because we don't need always a car. Sometimes we also need a bike. It means, for example, in one of our earlier launches, ISRO launched PSLV C-37 mission. In that, ISRO launched 104 satellites in a single go. Okay, very good, proud moment. Also, it had a world record. Very good. But there is one problem in that. I mean, that particular vehicle behaved like a share auto. I mean, it did not start till 104 satellites gather. But if you have a smaller vehicle, lighter vehicle, cheaper vehicle, you don't have to wait till 104 satellites gather. If you have 1 or 2 satellites, you can just launch it. Okay, that is the reason why we need a lighter vehicle, so we need SSLV. We need a relaunch vehicle, so we are working on RLV. But we want a heavier vehicle than LVM3, so we are also working on NGLV. These are all the previous, present, developing and future rockets by ISRO. Is it clear? Complete consolidation. Is that clear? Then, what is going to be what is the heaviest rocket by ISRO? What is the heaviest rocket by ISRO? Yes, all of you? Including the future rockets. Including the future rockets. It is NGLV. Okay? And what is the currently available heaviest rocket? LVM3. Currently available heaviest rocket LVM3. Future planned heaviest rocket NGLV. One very light rocket, okay, small vehicle is SSLV. Okay, and the relaunch vehicle RLV. These are the rockets. Now coming to NGLV. NGLV's first stage is solid. Not only NGLV, most of the rockets have their first stage as solid stages only, because solid fuel will give greater push against the gravitational force. And the second stage is a liquid fuel stage. It will use liquid fuel. Liquid fuels have one advantage. Have you watched the Mission Mangal movie? Okay, where Vidya Balan explains this Puri concept in that movie. Have you watched that movie? Yes, all of you. In that, she speaks about switching off the fuel when it is not needed to save the fuel. Switching off the fuel when it is not needed to save the fuel. Can we do that with a solid stage? Everybody, can we do that with a solid stage? Can we switch off this stage when you don't need the fuel? No, because I told you, you cannot switch it off. It means cannot on and off, written here. You cannot on and off. Once ignited, it will totally burn the fuel. Then only it can stop. If you switch it off, you cannot start it again. But liquid fuel advantage is that saving the fuel is possible with liquid fuel. When you don't need it, you can switch it off and switch it on again when you need it. But the disadvantage is it will not give such a greater thrust as a solid fuel. And the third stage of NGLV is going to be, a cryogenic. Cryogenic means it will use liquid oxygen and liquid hydrogen, okay, at very low temperature, therefore it is called cryogenic. Okay, so it is going to be a 3-stage launch vehicle. First stage solid, second stage liquid, third stage not cryogenic, this is semi-cryogenic. The third stage in NGLV is semi-cryogenic. Is it clear? And any strap-on motors in SSLV? No, Santosh. PSLV and GSLV will have strap-on motors. SSLV will not, because it is a light vehicle. The target is to keep it small, and we use strap-on motors to increase the capacity. But SSLV target is to decrease the capacity. So why do we use strap-ons? Is it clear? For example, you want car as big as possible so that you can go, maybe 7-seater you will prefer. But bike you want as small as possible so that you can simply go all alone in a heavy traffic congested roads. Is it clear? So we don't want to use strap-ons. Is it clear? Okay. NGLV, not sure. It means because it is a planned mission. Okay. The total configuration of the NGLV is not yet declared by ISRO. I mean, we do not know complete details of NGLV. Is that clear? Okay. Tell me, what is the first stage of NGLV? Solid stage. Second stage of NGLV? Liquid stage. Third stage of NGLV? Not cryogenic, semi-cryogenic. Okay, why this is called semi-cryogenic? Because it will use kerosene, which is liquid, and liquid hydrogen, okay, which is cryogenic. Is it clear? Look at here. It is semi-cryogenic because it uses kerosene, which is liquid, okay, and liquid hydrogen, which is cryogenic. Means half of it cryogenic, other half of it liquid. So we call this as semi-cryogenic. If you completely use only cryogenic, that is called cryogenic. If we use only liquid, that is called liquid. But if you use liquid component and the cryogenic component, then we call it as, okay, and we call it as semi-cryogenic. It will also use liquid oxygen as oxidizer, okay. It will have a liquid called kerosene and cryogenic components called liquid hydrogen and liquid oxygen. So it's not fully cryogenic. The third stage is semi-cryogenic. Is that clear? NGLV is partially reusable, not like RLV, not like GSLV. GSLV is not at all reusable. RLV is completely reusable, whereas NGLV is partly reusable rocket, which is currently under the development by ISRO. Okay, NGLV we still do not have, it is still under the development. This vehicle is designed to replace the currently operational PSLV, GSLV and LVM-3. So therefore, we used to call it earlier as a unified launch vehicle because a single launch vehicle instead of all the different vehicles. That is about NGLV, next generation launch vehicle. Then the next future mission is Gaganyaan. Okay, the next future mission is Gaganyaan. The Gaganyaan project envisages demonstration of human space flight. Here we are sending 3 astronauts into, see, we are sending 3 astronauts into a low Earth orbit at an altitude of around 400 kilometers above the Earth. Is it clear? And then bring them back safely. These astronauts, once they return the Earth back safely, their crew module will fall in the Indian sea waters, because if it falls on the ground, it may injure the people, and also it may injure the astronauts. So it will fall into the sea waters. That is called Gaganyaan mission. Okay, manned mission, sending astronauts into the space. This is going to be the first manned mission by ISRO. The first manned mission by ISRO is going to be the Gaganyaan mission. With this, India will become the fourth country in the world to successfully send the manned missions to the space after USA, Russia and China. What are the only three other countries which sent manned missions into the space? USA, Russia and China are the only three other countries which already spent manned missions into the space. With the success of Gaganyaan, ISRO can become the fourth space agency to send man into the space. Okay, but can we directly send astronauts into the space, or we have to make sure that we can safely bring them back? Yes. So before we actually send the astronauts, we will first send a humanoid robot called as Vyomamitra. This is a humanoid robot. It means it will look like a human being. It is in the human shape. So we will first send the Vyomamitra. If the Vyomamitra humanoid robot safely goes and safely comes back, then we will send the actual Gaganyaan mission. Is it clear? Then, what are the prerequisites of Gaganyaan mission? Before actually sending the astronauts into the space, what are the preparations needed? What we have to do now before sending the astronauts into the space? First one, development of human rated launch vehicle. We call it as HLVM3, means this is human rated LVM3. It means this is LVM3 only, the same vehicle which carried Mars orbiter mission to which will carry MOM to Chandrayaan 4. The same LVM3, the one which already carried the Chandrayaan 3, the same LVM3, but we will modify. We will modify the LVM3 in such a way that, okay, it will become eligible, suitable to carry the astronauts, human rated LVM3. Okay, manufacturing that and preparing the life support systems to provide the Earth-like environment to the crew. It means these astronauts in the crew module. Look at this. This is LVM3. LVM3 rocket. You know, here look at this part. That is called as crew module. That is called as crew module. This is the place where the astronauts stay, and on coming back or in case of failure, the crew module, is it clear? The crew module falls in the ocean. Tell me, in which two conditions the crew module, this crew module will fall into the Indian sea waters? In which two conditions this crew module falls into the Indian sea waters? First, if it is successfully launched, when they come back after the mission, or if it fails, okay, then they will fall in these two cases. If it fails, then they will immediately fall. If it is successful, they will go, stay there, complete the mission, and then during coming back, they will fall. But this crew module is going to fall in the water. this crew module is located here. Okay, right. So first what we have done, Earth-like support systems in the crew module. In the crew module, it means the astronauts in the crew module should feel as if they are on the Earth. The astronauts in the crew module should feel as if they are in the Earth. They are on the Earth, sorry. The crew emergency escape provision. By chance the launch of the Gaganyaan fails, then the crew module should be capable of escaping that. It should not be burnt along with the failed Gaganyaan mission. So the crew emergency escape provision is needed. And we have to train the astronauts. And recovery and rehabilitation of the crew. See, the crew module will fall in the sea, then immediately we should go and collect the crew module and safely bring the astronauts out of the crew module and rehabilitate them. Rehabilitate them includes the psychological therapy, providing nutritious food, giving them enough rest, again some physiotherapy like things so that they will again start walking, because for a few days they did not walk. They spent in the microgravity conditions. So rehabilitate them. These are all the prerequisites of the Gaganyaan mission. And we need human rated LVM-3. As I already told you, we are going to use the GSLV Mark III or the LVM-3, but not as it is. We are going to do some modifications to it. That modified LVM-3 is nothing but the human rated LVM-3. This is LVM-3 is identified as a launch vehicle having 3 stages. First stage solid, second stage liquid, third stage cryogenic. In the LVM-3, first stage solid, second stage liquid, third stage cryogenic. But in the NGLV, new generation launch vehicle, first stage solid, second stage liquid, third stage, yes, tell me, the third stage in the NGLV is? The third stage in the NGLV is solid or liquid or cryogenic? Yes, Chirag, correct. Okay, semi-cryogenic. But LVM, it is cryogenic. Is it clear? Then, HLVM-3 will be capable of launching the orbital module to an intended low Earth orbit of 400 kilometers. Okay. Gaganyaan will take the astronauts into the space to a low Earth orbit, of 400 kilometer altitude. And HLVM-3 contains a crew escape system. I told you that in case of any emergency, the crew module should have an escape system, but it should not be burnt along with the failed Gaganyaan. It should not be burnt along with the failed Gaganyaan. It should be capable of escaping. Okay, next. Now let us see a little bit more about the orbital module. Orbital module means Earth, this is the orbit, around the Earth, and it will have 2 components. First component is, okay, this completely is called orbital module. In that first module is called as crew module. The second module is called as service module. Okay, crew module, service module, and Together this is called as orbital module. Is it clear? Why that is called orbital module? Because it will keep orbiting the Earth, and that will have crew module and service module. Tell me, what are the two components of the orbital module? Everybody? What are the two components of the orbital module? The first component is crew module and the other component is service module. Okay? Crew module is a habitable space with Earth-like environment. I told you crew module here. This is the crew module. Look at here, crew module. And this one is the service module. Crew module is the place where the astronauts stay. Service module will do any maintenance work to the crew module. If the crew module require any maintenance work or servicing work, then the service module will do that. Both together is called, this complete component is called as the orbital module. 3 astronauts will spend 7 days in this orbital module. Is it clear? Now, so crew module, like as I told you, habitable space with Earth-like environment in that, and it is also designed for re-entry to ensure the safety of the crew during the descent till the touchdown. And then service module, it will be used for providing the necessary support to the crew module. I mean any maintenance work, repair work, servicing work to the crew module will be done by the service module. Is it clear? Then what other preparations we are doing for the Gaganyaan? Interestingly, we are in 2025, but the preparations for Gaganyaan started in 2004. 21 years back, we started the preparation and Gaganyaan is not yet launched. Actually, now we are in a kind of a crisis situation. Why we are in a crisis situation? Because the selected astronauts are aging. It means the Gaganyaan is getting delayed. With the delay of the Gaganyaan, the selected astronauts are also aging. Okay, they will also get physical changes in the body. One basic criteria to select the astronauts means they must be healthy, young and fit. Is it clear? But they are aging because of the delay of this Gaganyaan. If the Gaganyaan further delays, maybe some of the astronauts will become non-suitable. Then we will have to train some other astronauts. Then it will further delay. So like that we are in a kind of crisis situation related to this Gaganyaan now. So we started the preparation in 2004. And we do not have proper training facility in India where we can train the astronauts in microgravity conditions. So these 3 astronauts are taking their training, they completed their training in Russia, in Moscow. Is it clear? Okay. The astronaut training facility established in Bangalore. The 3 astronauts completed their training in Russia, basic training, but we have certain other aspects of the training. For that we have also established a training facility in Bangalore. We are also stitching the space suits. Space suits are being stitched. Space capsule recovery experiment conducted. It means can we safely recover the space capsule from the water? If the crew module, like as I have shown here, if the crew module falls in the water, what we have to do? Space capsule recovery experiment. Space capsule recovery experiment. Whether we can safely recover the space capsule from where? Re-entry means re-entry into the Earth atmosphere from the space. Recovery means from the water. Recovery means from the water. Recovery experiment. Is it clear? Space capsule recovery experiment from the water bodies. Then pad abort test. Okay, pad abort test. It is an ISRO launch escape system test for the crew mod. Pad abort. It means abort means when the mission aborts, or it means when the mission fails. When the mission fails, can the crew module escape? That test is done. And crew module atmospheric re-entry experiment, care. Crew module atmospheric re-entry experiment. This experiment, okay, is to test whether the crew module can safely, re-enter the atmosphere. Why this doubt? What is the problem in re-entering the Earth's atmosphere? Atmosphere is very dense. When a spacecraft re-enters the atmosphere, the spacecraft will experience resistance. This resistance will create friction. The friction will create heat. The heat can melt, okay, the crew module. So we have already tested whether the crew module can safely re-enter the Earth's atmosphere or not. Crew module atmospheric re-entry experiment conducted in 2014. Okay, 11 years ago we have already conducted the crew module atmospheric re-entry vehicle. CARE is an experimental test vehicle for Gaganyaan. Okay, fine. We tested whether the crew module can safely re-enter or not. But to test this, did we really send the actual Gaganyaan and tested whether the final actual Gaganyaan can re-enter or not? No. We sent an experimental test vehicle into the space to an altitude of 126 kilometers. We sent an experimental test vehicle into the space to an altitude of 126 kilometers. Okay, and from there we tested whether it can safely reach the atmosphere, safely cross the atmosphere or not. The main fear is because during the atmospheric re-entry, it will experience a temperature of around 1000 degrees Celsius. I repeat, we sent an experimental test vehicle for Gaganyaan to an altitude of 126 kilometers. But remember, actual Gaganyaan will go to 400 kilometers. But this is a test mission. It will go to 126 kilometers, come back, re-enter the Earth atmosphere. Okay, and then the re-entry will begin. Re-entry starts at 80 kilometer altitude. From the 80 kilometer altitude, it will experience enormous amount of heat, up to 1000 degrees Celsius heat, and this test was successful. This experimental Gaganyaan test vehicle successfully re-entered the Earth's atmosphere, tolerating 1000 degrees Celsius temperature. Is that clear? Next, ISRO also planning to conduct, okay, a Gaganyaan test flight in 2025. These are called as G1, G2, G3. What are these? Okay, these are unmanned Gaganyaan missions. Means the actual Gaganyaan mission will be launched. Okay, the actual Gaganyaan mission will be launched, but without astronauts, without the astronauts. I mean with only the Vyomamitra robot. Okay. December 2025 we are planning first such launch. Okay. But later we are planning G2, G3 also. Okay. And then answer this question. Which among the following is the launch vehicle planned to be used in the Gaganyaan mission uncrewed mission G1? In the Gaganyaan uncrewed, it means unmanned mission G1. Everybody? It will be human rated GSLV Mark 3, HLVM3. C is the correct answer. Okay. And then ISRO also completed a few more experiments. Let us see them. Okay. A few more experiments. Let us see them. Okay. One is IADT1. IADC, remember, G1, G2, G3 are unmanned. Remember these points because you are going to solve this question. Okay. Pair the following type of question you are going to solve. So remember these points. Okay. G1, G2, G3 are the unmanned missions. Okay. What is IADT? IADT. Use the word all of you. IADT. It is a simulated crew module with parachute system. Okay, here what we will do is Chinook helicopter. There is no launch here. There is no rocket here. Chinook helicopter will carry the crew module to an altitude of 3 kilometers. Is it clear? Simulated crew module. Okay, answer a few questions. What is the experiment name? IADT. Okay. In this, is there any rocket? Are we launching the Gaganyaan mission, at least unmanned mission? No, no launch. A Chinook helicopter will lift this like this. It will lift. Imagine my hand to be Chinook helicopter. And this will be the crew module. Chinook helicopter will lift this to the crew module and leave it from there. It will leave the crew module from there with the help of a parachute system. Is it clear? Okay. That is called as IADT. The test simulated the possible abort scenario. Upon release of the crew module, the onboard avionics commanded for deceleration system. It means it will slowly decelerate, come down. And thereafter the parachute is deployed. Post splashdown, the simulated crew module was successfully recovered by INS Anvesha to the Chennai port. Is it clear? Okay. And this one, this IADT is kind of an whole India phenomenon because Indian Air Force is involved and DRDO involved because Chinook helicopter is used. For that, Indian Air Force and DRDO involved. Indian Navy involved. Why? Because the crew module falls in the ocean. And okay, and that INS Anvesha, okay, will collect it and carry this to the Chennai port. So Indian Navy, because INS Anvesha belongs to Indian Navy, Coast Guard should, okay, should kind of recover. Coast Guard should recover the crew module. Okay, Indian Air Force and DRDO involved because you are using Chinook helicopter to lift the crew module and drop it. Chinook helicopter and just a drop test, and there is no launch, remember. In between there is another mission called TVD1. Okay, TVD1. What is TVD1? In October 2023, it is not an airdrop test, it is a high altitude flight test. This is a flight test. Whether Gaganyaan can fly or not. Whether Gaganyaan can fly or not. Okay, if this is clear, solve this question. And with this question, after solving this question, we are going to end this class. That is the ISRO's roadmap for the future. Okay, solve this question. How many of the following pairs are correctly matched? The test vehicle abort mission TVD1 is a high altitude flight test. Is that correct? Yes, it is a high altitude flight test. It will test whether the Gaganyaan can fly or not. IADT is just to validate the parachute system, whether the parachutes will work properly or not, to check that the Chinook helicopter will lift it and drop it from there. Whereas correct. G1, G2, G3 are unmanned test missions in the human rated launch vehicle. Actual launch vehicle but without the astronauts. Correct. Okay. All the three are correct. C is the right answer. That's all for today's class. Thank you so much for your active participation. Let us meet again in another session. Take care. Bye bye.